today we're looking at Module 4, Lesson 21. Everybody should be open to page 95 in their modules, and please put today's date at the top of the page. Okay. How many of you went out to dinner over vacation? Yeah? Friday night, a bunch of my running girlfriends, my triathlon girlfriends, we all went out to dinner. That place over Ragazzi by the mall. Yeah, I've never been there before. It was kind of nice. But you should have seen the look on the hostess's face when we walked in and said, we had 12 girls. So what do you think the waitress and the hostess had to figure out? What did they have to do so that the 12 of us could sit at one big table? They have to push the tables together. Exactly, and they had to figure out how many tables to push together to seat the 12 of us ladies for dinner. So on your table, you have these index cards. Each index card represents a table. Only one person can sit on each side. Like right now in this classroom, you're sitting two on a side. You can't do that at the restaurant. Only one per side. So how many people can sit at this table? 4, one on each side. So what I want you to do now is figure out how you could push these tables together. They have to be even, side to side, so that you can fit what's the most amount of people that you could see at these 5 tables. So now when I push these two together, one here, one here, one here, one here. Can't put any here now because I pushed the tables together. So right now at your table, push these 5 tables together and see how many people you can fit. Okay, so by pushing 5 tables together, how many people were you able to seat at the big table? 12. But I don't understand. How did you get, it's not like 5 times 2 was 10. If you put 3 at a table, 5 times 3 is 15. How did you get 12 for 5 tables? What did you do?
2 people at the end of the table counts as a seat.
Oh, so there are 5 tables. We could put 2 at each table plus 2 on the ends. So I had 5 here, and then 1 on each end. I see how that worked. Take 1 table away. Some of my girlfriends didn't show up. So take a table off the end. So now you have 4 tables. How many people can fit there? How many people at 4? 10. How'd you do that? If there are 4 tables, you were able to fit 4 on each side? Right, so 4 times 2, because there's 2 at a table, here and here, plus the 2 on the ends. Take another table away. My friend's babysitter backed out. They couldn't show up. Now we have 3 tables. So that's 8 people. How come? 3 on each side plus 2 on the ends. Take another table away. They all had a race the next morning. They didn't want to have dessert and weigh them down, so they left. Some of us stayed and had dessert. 6. How'd you get 6? 2 on each side plus the 2 on the ends. Take the 2 away. Well, there's 1 table. How many people? 4. So let's use that information and fill in the table on page 95. So 1 square table had 4. 2 had 3 had 4 had 5 had 12. Okay? Now, if we were having, my mom just turned 70, we had a big birthday party for her 70th birthday, a lot of people showed up. So instead of the waitress taking 50 index cards and trying to figure out 50 index cards for 50 tables, there has to have been an easier way. So let's go back and look and see what we could do. No matter how many tables there were, what did we do? no matter how many tables there were, what did we do? We took the number of tables and multiplied it by 2 and added 2. So can we come up with an equation for how we would write that? Yes, please.
T2 plus.
But instead of writing T2, what's the righter way to write that? What do we always have to put first? And some of you are still forgetting to do this. The coefficient always comes first. So we are just going to jump down to the bottom of the table. And let's see if that works if there were 50 people at the table. This is on the bottom of page 95 on your notes. So if we had a rectangular table that had 50, we know that we could put 50 on each side. So how many chairs fit on the ends? 2. 1 on each end. Okay? So on each long side of the table, we could fit 50. On each long side, plus 2 on the ends. So how many chairs fit in all? So let's see, if our formula was 2t plus 2, my table is 50. I have 50 tables plus 2, plus 100 plus 2, 102. And then I label my answer like that. That's how I want to see it. FTA. Formula to the answer. And then label it. Formula to answer. Okay. Now suppose I erased the whole screen and it's not there. Now what happened? Okay, so let's try it with the 200. You're going to continue on page 96, but I'm going to write it on this paper, on the slide. Okay, so if it says that there were 200, so let's write the formula. If there were 200 tables, then we follow the order of operations. Okay, because they asked if there were 200 chairs to up. Sorry about that. Okay, you're writing this on page 96. Then you can go back and complete the table. But formula to answer. Please show all the steps, top to bottom. Know where's Waldo work, where this is over here, that's over there, and I have to play hopscotch around your page to find all the different steps. Like a ladder. Boom, 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 boom. Now, I don't know about you, but over the vacation, I ate a lot of pizza, which is a good problem to have. Eating too much pizza, quite frankly, I think is a fabulous, and let's face it, I always eat too much pizza. It has nothing to do with being on vacation. A lot of days over vacation, my son had all of his friends from the baseball team come over. Not all of them, thank goodness, because that's a lot of teenage boys. They eat a lot. But, you know, we're like, all right, we'll order pizza. They're all hanging out playing baseball, ruining our New York lawn before it even grows in. But anyway, Pizza Queen has a special offer on lunch pizzas, $4 each. They charge $2 to deliver, regardless of how many pizzas are ordered. So one day it was only like him and 1 or 2 friends, so we just got 1 pizza. But then another day he had more friends over, plus we all wanted pizza, so we ordered more pizzas. It didn't matter how many we ordered, it was just still a $2 delivery fee. It's not $2 per pizza. All right? So here we're going to figure out an expression that describes the cost of having P pizzas delivered. I don't know about you, but I just prefer cheese on my pizza. I really don't like having a P pizza. That sounds kind of gross, but whatever. One person's paying attention. All right. So if it's $4 per pizza, so if it's $4 per pizza plus the $2 delivery fee. Notice in our heading, it's telling me my units and my quantity, number of pizzas, cost in dollars. So how much is one pizza? How much is one pizza plus delivery fee? It's $4 per pizza. So here, P equals 1 because it's one pizza.
$6.
How much is two pizzas? $4 per pizza plus $2 delivery.
10.
3 pizzas is how much? You should be filling this in the table on your notes.
14.
4 pizzas. 4 times 4 is 16, plus the $2 fee is 18. 10 pizzas. $4 per pizza. So 4 times 10, plus the $2 fee in the back. 50. So 50 pizzas times $4 a pie, plus the $2 fee. $202. So what is the formula that we came up with? Per is what operation? Per is what operation? Multiplication. So how could I say that? 4p plus 2. Because it's $4 per pie plus the $2 fee. So instead of filling in this table, we could have just done our formula, plugged it, and solved it. Real quick, let's turn to the last table. Now they raised the price to $5 per pie and $3 for a delivery fee. What would my formula be? $5 per pie and the $3 delivery. What would my formula, my expression, what would my expression be? Good. Okay, so on your homework tonight, on loose leaf, showing all of your work, formula, plug it, labeling your tables correctly, and so on.